She called me. She said that she will join, like right now.
Okay. Welcome, Chitti sir.
Hello, Sohini, please join. Okay. Thank you. Yes, please. I mean, we are all here. You please join. We'll test it now. Okay. Thank you. Hello, Sohini. Good afternoon. You can please unmute yourself.
Of course, yeah. Yeah, am I audible now?
Yes, absolutely. Thank you very much for agreeing to give a talk.
Just a minute.
Yes.
Yes.
We can hear you loud and clear. You might like to try your presentation once as well.
Yeah. Is it visible, Dada?
It's coming up. Yes, it is visible. You can put it to the full screen.
Okay, I have put it in the full screen mode.
No, I think then perhaps you have not selected the entire screen to be presented.
Okay, just
You
a minute.
can stop sharing and present the entire screen. I think that would allow you to present in the full slide mode.
So from the share option,
yeah, you just go to entire screen.
Okay.
And then there will be a window popping up. Then you need to select inside. Yes.
Now it is okay. Dada?
Yes. Okay. Now can you put it in the full screen? Yes, fantastic. Thank you very much, Sohini.
Okay.
Yes, looks good. So we'll start in next 5 minutes so that everyone can join. Thank you.
Sure.
नमस्कार प्रदीप जी.
बॉस नमस्कार.
नमस्कार. कैसे
है भाई?
बस चल रहा है.
दर्शन तो दीजिए.
ओ, दर्शन नहीं है क्या?
दर्शन नहीं हो रहा है आपके.
The same old man.
ये बात हुई.
Same old man.
क्या हाल है बस? बढ़िया.
बस चल रहा है. आप लोग का यहाँ कैसे चल रहा है?
सब ठीक चल रहा है बॉस.
सब ठीक ठाक.
I
ओके.
think the speaker is around.
हम लोग का डिपार्टमेंट से 2-3 बच्चा गए. एक बच्चा तो गई है, नम्रता.
Okay.
एमएससी में एडमिशन लिया था.
अच्छा अच्छा. म्यूजिक बैकग्राउंड म्यूजिक आ रहा है क्या?
हमको लगता है
Sorry.
ज्योतिर्मय का है.
Yeah, I'll just.
ज्योतिर्मय का म्यूजिक.
It was good. It was good.
Okay. It's just to keep the environment bit relaxed.
Right, right.
Oh, wonderful. We are about to fly.
Yes. और इधर आना हो रहा है, आएंगे इस फील्ड के लिए अंतरु.
कहाँ पे? वो हाँ, इस साल तो नहीं होगा लगता.
अच्छा.
नेक्स्ट ईयर.
ये सेक्शंस ओपन है इस बार, हमने देखा था बिकॉज ऑफ दैट रोड कंस्ट्रक्शन एंड अदर
हाँ.
थिंग्स. ये पूरा शिवालिक देहरादून तक अच्छा एक्सपोज्ड है. आई वाज रिमेम्बरिंग यू.
अरे क्या बात.
आई एम टेलिंग यू,
यार.
जो देहरादून की तरफ जब मोहन वो ब्रिज अंडर वो है ना क्रॉस करते हैं जब, और देहरादून में जाते हैं, आई कुड सी द नॉर्थ डिपिंग बेड्स. और
अच्छा.
जो कि अर्लियर हम समझते थे दीज आर रियली यंग बेड्स, बट टर्न आउट दैट वो भी शिवालिक का ही पार्ट है. एंड हमको ऐसा लगता है कि कुछ अगर स्पेशलाइज्ड मैपिंग वगैरह आप कर सकें तो इट विल बी वेरी नाइस.
एक प्लान बनाओ.
है
एक प्लान बनाओ प्रदीप.
आ जाइए, हम होस्ट कर लेते हैं आपको.
हेलो. क्या बात है.
कम
बात
with
करो
you.
यार. मौसम का हालत नहीं. उत्तराखंड का तो इस बार वेदर बहुत फ्लक्चुएट कर रहा है ना. इतना
अभी अच्छा है. अब ठीक हो जाएगा. इट विल काम डाउन. भाई नवंबर तक तो बहुत अच्छा हो जाता है.
अक्टूबर नवंबर अच्छा होगा.
नवंबर ठीक रहता है. नो मॉनसून.
हाँ नवंबर ठीक रहता है. बात सही है. देखता है एक बार. अगर जाएंगे तो बताएंगे हम.
यस यस यस. दिस टाइम यू स्टे विद अस.
स्टूडेंट या
यहाँ पे स्टे करिएगा आईटी रुड़की में.
वो आईआईटी रुड़की में. अब तो बहुत बढ़िया है यार.
यस.
बहुत बढ़िया.
All right. If you all agree, then we can start the meeting today.
या.
So welcome
Yeah,
everyone,
I think
and
you
I
should-
know this is a weekday, and thank you very much for taking your time out for this talk. And it's my pleasure to announce and introduce today's speaker. We have Dr. Sohini Das, and from Geological Survey of India, currently based in Shillong. Sohini did her graduation from Ashutosh College, Calcutta University, 2007. And then masters from Indian School of Mines, IIT ISM Dhanbad, in applied geology in 2009. And then she obtained her PhD from ISM Dhanbad again in 2017 in structural geology. And I think while she was doing PhD itself, she joined Geological Survey of India in 2011, if I'm not mistaken. And then she has worked in the western region of GSI in Jaipur. And currently she is posted in GSI Northeastern region, Shillong. She has interest in specialized thematic mapping in Deccan volcanic provinces. She has worked in North Delhi Fold Belt, Aravalli Fold Belt, She's also interested in exploration of base metal sulfides and gold. And currently she is working in the domain of deep-seated mineral. So with this brief introduction, may I now invite Sohini to present her work. Thank you very much, Sohini.
Thank you, Jyotirmada. And at the very onset, I'd like to apologize for my voice. I am having this terrible cough and cold because of the weather in Shillong. So please bear with me, sirs. And as I can see, many of my seniors and my PhD guide, Dr. Mukherjee, he has also joined. So it's been a really honor to be invited for the talk. And so cordial thanks to the organizers. And so I'll present my PPT now. Okay, so is it visible?
Yes, Sohini, absolutely clear, and we can hear you as well. Your voice is not troubling at all. So thank you very much. Please go ahead.
Okay, thank you, Dada. So today I'll present the gravity gliding of Mesoproterozoic Kaladgi sediments, an example of thin skin tectonic from southern India. Okay, so at the very onset, let us acquainted with the Kaladgi Basin. So Kaladgi Basin is situated in the southwestern part of India here, and it's the intercratonic basin, east-west trending. And the basement of these basins are this peninsular gneissic complex in the southern part, and also the close-bed granite in the southern and northern part. And in the central part, we have the Hungunsis belt as the basement of the basin. And in this part, this entire blue color part is the Bagalkot group of Kaladgi supergroup. The Bagalkot group is of Mesoproterozoic age, which is deformed. And we also have the undeformed Neoproterozoic Badami sediments here. Okay, and for our purpose of the study and better understanding, we have classified the entire section into three regions, like in the northern sector, south central sector, and the southern sector. So this is the map of the northern sector. As you can see here, so this is the basement close-bed granite, over which the siliciclastic sediments of Kaladgi group has been deposited, and this in this part the beds are homoclinal and gently dipping towards south, and the rest, this green color part, is covered by the Deccan Trap. Okay. So this is the map of the south central part. Here you can see this is the basement of close-bed granite in the north, and basement close-bed granite as well in the southern part also. And in this part, the Kustagi Hungun system, is exposed. And this entire package of sediments is a Bagalkot group of Mesoproterozoic age. And this is the map of the southern part. Here the basement is peninsular gneissic complex, this pink color one, over which we can see this thin strip of sediments, siliciclastic sediments of Sonoti quartzite of the Bagalkot group. Okay, so now over the last few decades, the Kaladgi basin has been worked upon on various aspects like broad deformation patterns, paleobiology, sediment geochemistry, facing analysis, and also on the mineralization aspect. But there are some excuse me there are some gap in the knowledge and the understanding. So these are the lack of systematic documentation and analysis of the structure, lack of data on interrelationship of the structural element, data gap in the mode of occurrence, distribution, and various structural elements across the general trend of the basin, and incomplete relative chronology of development of the structural element, and no information practically available on the basement cover structural relationship. And there is also lack of information on the origin, cause, and deformation pattern of the cover. So based on this knowledge gap, we try to understand the structures of the basin, the structural analysis of the basin, and for that we have prepared this basic flowchart to how to approach the knowledge gap and how to address this problem. So what we have tried that we have tried to see the mesoscale structure for both basement and cover. So in mesoscale, we have tried to identify and document the structure, their interrelationship, their various chronology of the development of the structure, mode of occurrence, and distribution patterns. And for the microstructures also, we try to identify all those parameters. And based on this, we try to understand what is the basement cover structure relationship. And we try to answer the question whether the basement conforms with the cover deformation or not. If the answer is yes, then it will be a thick skin tectonic. If the answer is no, then the interpretation would be a thin skin tectonic. So if the answer is no, in case of thin skin tectonic, the main question to answer is how did the deformation of the cover originate in the intercratonic basin? Because I have already told Kaladgi is an intercratonic basin. There are no plate boundary, plate margin available for contraction or divergence kind of settings. And then we also try to correlate it with the regional tectonic aspects and try to answer the final question that how the basin opening, closure and upliftment and deformation in a regional tectonic context. And this part and this entire part I will present in my talk. Okay. So now let us first understand the composition of the basement. The basement, as I have already told, the basement is composed of mainly three parts. That is the PGC, Peninsular Gneissic Complex, and which is a polydeform polymigmatized gneiss of a TTG composition broadly. And we have the Hungun cyst belt. Hungun cyst belt has these components: the banded iron formation, metapolites, and metavolcanics. And we also have the close bed granite, which is a leucocratic granite of 2.5 GA. Now, let us understand briefly the structural element of the basement. So, basement has undergone D1, D2, and D3 deformation phases, and those are overprinting on one another. So, here I have presented a brief model, a schematic model of the deformation of the Hungun cyst belt. So, first there was flat bedded sediments, and there was a compression from southwest and northeast direction, and for which we got the first deformation of D1 phase, on which this folds has generated, and initially, and with the advanced D1 we have accentuation of these folds. And during D2 also the compression direction remained the same from southeast and southwest to northwest direction, and for that the earlier fold of D1 got refolded in a coaxial deformation pattern. And during D3 we have a perpendicular compression like from northwest and southeast direction. For that we have a general kinking of the S1 and S2, as we can see here during D3. Okay. So now the structures of PGC. So PGC in our area, though it's a vast extent, but in our study area, it's very rarely exposed. And whatever exposure that we have found, we have seen that the structures in the PGC, the general structural grain of the PGC is parallel to that of the cyst belt, that is northwest southeast. And in our study area, the close bed granite is devoid of any penetrative structures. So now coming to the relationship between basement and cover, the unconformities. Here in the northern part of the basin, we have seen this is the close bed granite over which the Sonjoti quartzite, the basal horizon, has been deposited, and these beds are 10 to 15 degree dipping towards south, and this defining a non-conformity. And in this part, you can clearly see this is steep beds of Hungun cyst belt which are folded, polydeformed, and over which this is the Sargundi conglomerate horizon. It's from this picture is from this part, where you can see the thin Sargundi conglomerate horizon, which is horizontal over the very steeply dipping Hungun cyst belt, and so it is defining a clear angular unconformity. Okay, now coming to the composition of the Mesoproterozoic cover. As I have mentioned earlier, Kaladgi supergroup has two components: Bagalkot group of Mesoproterozoic age and Badami group of Neoproterozoic age. Here in this part, this Badami are deposited. These are flat horizontal beds, Our study was restricted in this in the deformed Mesoproterozoic sediments, that is the Bagalkot group. So Bagalkot group started with a conglomeratic horizon, there's a Shanalondi conglomerate, and then a Shundutti quartzite unit. And as we go in the Yangling direction, we have a general decreasing grain size. And we finally have a argillite facies, and then after a disconformity again we have finding upward sequence like a Muchkundi quartzite and the argillite of Hosakati formation. So now in Mesoproterozoic cover rocks of Bagalkot group, we have different lithounits that, as I have mentioned earlier, there are argillites, there are quartzite, there are limestone also, and we have observed development of folds in limestone, argillite, quartzite, and we have also observed development of cleavages within limestone, argillite, and quartzite. And we have also found some extensional structures and brittle structures like hybrid joints in this part in near north of Manikeri, and we have also observed fault breccias. Okay, now let us understand the map and cross section. Okay, so this is as I have shown this map earlier also, this is from the south central, sorry, this is the northern part, map of the northern part. Here see, this photograph has been taken from this area. This is the poles of the bedding. Okay, so these beds are around 10 to 15 degree, 10 to 15 degree dipping mostly towards south. And here we also have a tear apart structure in this part. We also got normal faulting here and here, and along this normal faulting we have this reverse drag and normal drag also. Okay, so this is the map of the south central sector where the main sediments has been deposited. So this section is MN, that is M and N. So here you can see as we move from north to south, the beds getting folded, and more towards the south, the closure are more tight, the folds are more tight in the southern part. Okay, and in the southern sector, here the beds are really steep, and we have a close sequence of antiform and synform in this part. Okay, now the structural relationship indicate that the cleavages that we observed in the field that are axial planar to the mesoscopic fold in the area, and the general orientation of the folds are west northwest to east southeast. This is the general orientation. Excuse me. Okay, so if we talk about the distribution of structural element of the cover, so what we found there exists a line north of which all the structures are of extensional type. So we called it the zone of extension, and south of which all the structures are contractional type, so we called it a zone of contraction. And these structures are practically linked from one to other. Okay, now coming to the deformation microstructure. The microstructures, here it is a granoblastic structure. These are the microstructures of the basement. So what we have found, the basement microstructures are related to a relatively higher temperature deformation mechanism, mostly greater than 350 degree. And in the cover rocks, the deformation microstructures are relatively lower, that is less than 300 degree. Okay, so if we try to compare the deformation in basement versus cover, so in basement, multi-stage deformation and human belt we have observed, but there are no multi-stage deformation in the cover, only one stage of deformation. And And this deformation of Hungun cyst belt is also conformable to the deformation with the PGC. And the deformation general structural grain is northwest southeast, whereas we observe in the cover the general structural trend is west northwest to east northeast to east west. And we haven't found any this orientation, this east west orientation, any penetrative structure of east west orientation to the basement. Okay. And this is the flutis plot of the Hungun Sisbel folds, which plot in this region. Whereas the flutis plot of the cover, the folds that develop in the cover rocks, those plot in this field. And as I have mentioned earlier, the microstructure related to higher temperature deformation mechanism in basement, and the microstructure related to a low temperature deformation in the cover. So the deformation of the basement and the cover are really contrasting. So from that, we have come to the fact that the contrasting mesoscale structural geometry and orientation of the basement and cover, and the observation that the basement is not involved in the deformation of the Mesoproterozoic cover from the mesoscale structure. And from microscale structure also, what we have seen that the inherited microstructure from the basement superimposed by the microstructure of the cover, but not vice versa. That is, we haven't seen any low temperature deformation mechanism superimposed over the higher temperature deformation mechanism grains of the basement. So from that, we have the following interpretation. We have drawn the interpretation like the basement not involved, so it's a thin skin tectonic. The basement was decoupled from the cover during the deformation of the cover, and because there are no tectonic boundary available to develop the structure, we propose a model of gravity gliding for the origin of the deformation. So let us understand the gravity gliding mechanism. So gravity gliding is defined as a rigid translation of layer downslope with displacement vector parallel to the detachment surface. And here we have up dip extension and distal down dip contraction. And the basement is not actively involved in the deformation of the cover. So all these principles are matching with our case. And here in this figure, all the current day gravity gliding phenomena are shown. Okay, so from our field observation, our mapping, and all the structural analysis, we have concluded this deformation model. So this is the basement of close spread granite, and in this part the Hungun cyst belt is there, and in this part this is the PGC, and over which this is this dark black color line, this dark black line, this is the unconductive surface which acted as a detachment plane, and over which we have seen the sediments of Mesoproterozoic sediments of Bagalkot group and lighted down. And for that, in the northern sector, a zone of extension developed, and in the southern sector, a zone of contraction developed. And so as we move further towards south, this contraction is more prominent and more increasing. And here this contact, this is a faulted contact with the sediment, this acted as the buttress to support the deformation. So from this model we try to analyze what was our position of Kaladgi basin in respect to our Indian plate, and how this deformation, how this gravity gliding might took place. So what we have interpreted is that during 1500 to 1200 MA, there was a crustal stretching, and due to which sagging has been taken place, and also result in normal faulting, due to which a basin open up and the sediment has been deposited. And it is also this model has also supported by field evidence that in the northern part the sediment thickness are very shallow, while in the south central and southern part the sediment thickness are considerably high. And during 1000 to 800 MA, that is during Grenvillian orogeny, this South Indian South Indian block, which contained the Kaladgi basin, was under a compression from both sides, from this side from East Antarctica and from the northern side from North Indian block. And due to this crustal compression, we interpreted that there may be a crustal flexure, and due to the crustal flexure, the northern part of the crust has been uplifted, and which provided a slope for this sediment to glide down, and this unconformity plane acted as the detachment surface over which the sediments has glided down. Okay. And we have published this work in Precambrian research. So, okay, thank you.
Thank you very much, Sohini. Very nice talk, very well presented as well.
And
Now
my voice, I cannot raise it. So
no, it was absolutely fine. It was we understood, I guess, most of it. So now we open this forum for questions and answers. Please raise your hand and ask question if you have. Yes, Mr. Basir, please go ahead.
Hello, sir. Sir, I have a questions, but apart from this topic, basically, sir, sedimentological properties. Sir, can we connect anyhow the changes in the sedimentological properties with anthropogenic interventions like textural analysis, facies analysis, and morphostratigraphic units, and any other segments in sedimentological parts? Can we connect with the recent anthropogenic interventions and modifications and their imprints on the sediments environment over the river basin?
Sohini, would you like to take that?
In GSI, we have a quaternary division in which this paleo after from the younger sediment that has been chemically analyzed, and we have many dates also. But till date, whatever sedimentation we have observed, we haven't seen any major significance role of anthropogenic activity to directly correlated to the quaternary sediments. So we haven't in GSI we haven't correlated that till date.
Okay, ma'am. Thank you so much.
If any other information is available in this regard, so if anyone else can throw light on that. But recently we have published a paper on hydrogeochemistry, and in hydrogeochemistry you can directly correlate with anthropogenic activity. We have found a major mechanism of hydrogeochemistry is directly controlled by anthropogenic activity in many, especially in the urban regions.
Yes, ma'am, I have understood.
Yeah.
Okay, thank you. And basically, the hydrologic the components like dam and reservoir constructions.
So that is a engineering geology aspect. I'm talking about how the chemical nature of a groundwater is defined by the processes, and in those processes, anthropogenic activity is one of the contributing factor.
Okay. Thank you so much.
Yeah.
Thank you, Sohini. Any other questions? Professor Mukhopadhyay or Professor Chetty or any of the students? Okay, Ayan, please go ahead.
Okay, so I have two questions. Firstly, Sohini, in between your zones of extension and contraction, are you getting any zone where the strain is low? or it is a sharp change?
No, because and at that partner, we have the see in this part, na, especially in this part, we have the sediments which are practically undeformed. So because these are flat bedded beds in this part, so it you can call it this zone as a no strain zone, of course.
Okay, and your contractional deformational structures, you showed kind of the southern margin of the basin, which you told acts as a buttress.
Yes.
Is the contractional structures are only confined to near the buttress, or is it widespread? I mean, what
If
is
you
the
can,
scale of the?
yes, if you can see here, see in this part, the folds are generating, but those are very open in nature of the fold. And as we move towards the buttress, these folds are very tight and isoplanar nature. Okay.
Okay,
So
so
here,
yes, yes.
this is the model.
Okay, so if I talk about the chronology of these folds, like for example, the three antiforms you showed in the C
Sector.
picture, in the
Mhm.
C, the three antiforms, or here, is the is this fold progressing from west to east, or is it progressing from
No,
east
this
to
is
west?
north south. This is the northern
Okay,
direction.
okay, north south. Is it progressing from north to south or south to north? I mean, the
Uh,
earliest
uh,
fold is forms near the buttress or near the slope.
uh, uh, how but that we have couldn't find out because finally we have seen this fold to form, which has formed, and we have seen the associated cleavages. But after the formation of these folds, we couldn't differentiate between whether it is a mechanically we can always say that theoretically we can always say, but direct field evidence we haven't got.
Okay, I am saying this because the maximum velocity gradient or contraction should be in the area where we are getting from extensional domain to contractional domain. So the
Huh.
maximum strain or the maximum strain rate should be there. But in your example, it is showing that the
No, strain,
tidal faults.
I'm not here now because of this buttressing effect. Here,
Yes,
this part, the fold are more close, more
yes,
tight in nature, na, because of this
yes.
buttressing nature. But
Okay,
the
okay.
strain,
If that,
we
yes,
talk
okay,
about
if
the
that's the
strain rate,
yes.
or strain rate, you are absolutely correct. The strain rate will be higher in this part, but that couldn't, that we haven't directly correlated with the
सर
field
एक
strength.
मीटिंग चल रहा है.
Yes, so what I can, if the buttressing is the main factor, then it's likely that the
Buttressing is not the main factor. Main factor is the gliding of the sediment.
yes, but if what I'm trying to say is that so
Hmm.
if the sediments are gliding from north to south,
Hmm.
then whenever then from extensional domain to when we are getting contractional domain, the fold should form first. But that's
Hmm.
not happening here because
No,
because
I am not talking about the formation of the fold. No, formation of the fold might have happened first in this part, but
yes.
the fold, as the fold accentuated, as the event accentuated, because the sediment glided down, we got the more tighter fold in the southern part.
Yes, so what I think is, or what looks more likely is that the earlier folds formed near the buttress and then the deformation front moved towards northern side. I think
Yes,
that's
yes,
what it looks like.
hmm,
Maybe more field studies will
yes, of course.
reveal more of it. Thank you, thank you.
Sohini, I have a question.
Yes, yes,
Sorry, I don't know if you have already covered that part because I missed the first 3-4 slides of your presentation.
yes.
How do you categorize the mechanism of folding? Is it buckling or
It's buckling.
flexural slip?
Buckling.
Dominantly buckling.
Buckling, yes, yes.
Okay. Yes, sir. Please go ahead.
Well, Sohini, I'm Dilip Mukhopadhyay.
Yes, sir. Hello, sir.
I'm just wondering, can you explain in terms of your structural elements and everything, in terms of metamorphic core complexes? Is it possible to describe?
Sir, we have tried to study the metamorphism of this covered
No,
rock as
no,
well
no,
as
metamorphic core complexes.
metamorphic.
Core complexes, CORE, core complexes.
Oh, I haven't gone through that, sir. I need to read about it first.
Okay, that's all.
Okay, thank you, sir. Any further questions? Anyone? No questions? Okay. If there are no further questions, then I would like to thank again Sohini very much for taking your time out. And I will also request that we have these lectures every month. If
Yes.
you be so kind to also join in
Of course,
subsequent lectures, that will be great. And thank you everyone for joining today. And I will send you the invite for the next talk pretty soon. Have a good evening. Bye.
Thank you. It's my pleasure.